The Big Bang, the birth of our universe. From this new matter, the first galaxies took shape. Nebulae formed inside the galaxies, and inside the nebulae, the Sun was about to make its appearance in the same way, surrounded by a rotating disk of dust and gas. Gravity pulled the dust particles together, and they turned into huge masses that grew and attracted other masses, future planets. The gases gathered in the Sun, which finally lit up. The planets grew thanks to large and small meteorites that rained down from the sky. The energy of each new impact was transformed into heat that gradually warmed up the young planets. Eventually today, Jupiter, Saturn, Mars, and of course, Earth. But what happened to the heat that was accumulated while our planet was being formed? It's still there, hidden in the innermost layers of the Earth's core, and it's constantly reinforced by natural radioactivity. The heat is continually transmitted to other layers before being freed into space. During its journey toward the surface, the heat moves semi-fluid rocks it meets along the way. Like water boiling in a pot, the rocks in each layer rise upward and shed their heat. Then they fall and get heated again. Like huge and very slow cogs in a machine, their movements shift the plates or enormous sheets that make up the thin outer layer of the Earth's crust. In this way, they move whole continents. After 200 million years, this is the result. Are interlocked. That's why, when they shift, the jerky movement along the edges that separate them causes what we call earthquakes. Most of the earthquakes recorded in the world aren't very strong. A particularly great one causes destruction and death. Earthquakes also occur at the sea bottom. When that happens, they can sometimes displace the water column and originate waves. These waves are best known by their Japanese name, Tsunami, which simply means harbor wave. Regular sea waves caused by the wind are very different from tsunami waves. Let's find out why. Wind blowing over the sea can only move the upper layer of water, forming waves but not affecting movements deeper down. The water particles near the surface move with a circular motion, which helps to propagate the wave along. Deep down, the water particles don't move. The strength with which these waves relate on the movement in the first few meters of water. A tsunami, on the other hand, can be generated at the bottom of the sea. In case of a strong earthquake, the sea floor abruptly deforms and vertically displaces the overlying water. The entire water column is disturbed by the uplift or subsidence of the sea floor. This sudden movement releases a great impulse of energy, which is transferred to the whole column of water between the surface and the sea floor. In this case, the water deep down moves as well, as deep as 1,000, 2,000, 3,000 meters. Apart from submarine earthquakes,